what we've done so far in LIGO, we're using 2 detectors that are aligned, commonly aligned. And great, you guys were able to do better than an annulus. That was all fine. But then when we add a 3rd detector, we're no longer aligned, so polarization matters. And I am not so clear in what you've said that once the data is analyzed, the waveforms are done and so forth, I understand what we can do. But in terms of determining where it comes from in a fast trigger, can you really get rid of or ignore or take care of the polarization? Or know enough to take care of the polarization?
Yes.
Are we fast you can?
Yeah, that's what, I mean, all 4 of these pipelines do that.
Probabilistically, I mean, it's in a way. I mean, it's using a prior to do that, but it's a good assumption. I mean, for the distribution of sources.
The things that we can't do in low latency right now are deal with, we don't deal with calibration uncertainty. So our full parameter.
It's being done.
It's being, I'm sorry, that's right.
There is an online calibration which is actually performing pretty well now.
Well, there's online calibration, but what I'm saying is we don't marginalize over the uncertainty in that calibration in low latency. So when we send out, our initial SkyMap, our refined SkyMap from our parameter estimation will usually be coarser, and that's because we've folded in those systematic errors. That should become less of an issue in the LSST era because there are a number of tricks that we can play to do our calibration better online, so that there is less of a difference between, the first version and the final version of the calibration. Did I answer your question?
I have to read what you've got.
Okay, I
don't buy it totally. I mean, you have different detectors with different sensitivity and different orientations. It's very different.
Discussion.
It's very different than the problem that we have now. And I understand you can start with a prior, but I have a hard time seeing how you can determine any unknown polarization configuration quickly and accurately when all the amplitudes and sensitivities are different and unknown. But I guess if you've done it, I'll read it, but I don't.
Yeah, all the pipelines, even the rapid ones, do that. Yeah.
So let me suggest we transition to the discussion. Leo will be a part of it, so we'll have a chance to talk to him more. If you know that you're on the first panel, please come forward.